All right. I had a request or two asking about some of the homework problems. So I thought we'd work them out together, at least a couple of them here, to see how you were handling it. Number 9 in your homework, the multiple choice question. It's a differential equation because you have a derivative set equal to something with terms of x's and y's. So that's called a differential equation. And we need to separate the differentials. When I say differentials, we got a dy and we got a dx. And it looks like all I do is multiply both sides by dx and then multiply both sides by that was a y. Let me erase it. I can't see when I run it. Oh, just a y. That term is actually referring to separating the variables. That's how you solve a differential equation. So you want your y's with the dy's, you want your x's with the dx's. Sometimes it's impossible to separate them, and that requires heavy duty differential equations. But in calculus AB, they're very basic ones. So I'm going to get the y. I'm going to pair that up with the dy here. So y dy will be equal to, now put the dx with the x squared dx. And you are just using basic algebraic operations, but a person in a doctorate of mathematics would shudder if I said multiply both sides by dx, even though that's what it looks like I did. Now, to solve this differential equation, how do I get rid of the differential? Well, we integrate both sides. So in integrating both sides, you're integrating y dy, and I think I did this problem for you guys in the video, but apparently some people didn't see the whole video. So that's y to the first, so that becomes y squared over 2 equals to x cubed over 3. And both of those have a c, but if you put all the c's together, you end up having just one constant of integration somewhere, okay? So I'm just calling it plus c here. Now he gives us an initial condition because I don't know what the equation is. So we're looking for an equation for f of x. Y equals f of x. So basically, I'm going to have to solve for y, but I can solve for y now or solve for y later. I'm going to solve for y later and plug in my x 0 and my y is a negative 4. So that gives me a negative 4 squared over 2 equals to 0 cubed over 3 plus c, which gives me a nice clean 16 over 2 equals c, or 8 equals to c. So I plug that into my equation here, okay? Plug that up here, and then what do I have? I have y squared over 2 equals x cubed over 3 plus 8. So now I'm going to solve this thing for y. I'm not even looking at my answers. I'm just doing what I know to be true. Y squared becomes 2/3 x cubed plus the 16. So now I look at the answer choices. Oh, I'm not done yet. I haven't gotten rid of the square, so square root both sides. So I'm looking for something that looks like y equals to, it is a possibility of plus or minus square root of 2/3 x cubed plus 16. And if I look over here, I do see several answers that could possibly be true. So I have the 2/3 x squared plus 16. 2/3 x squared, that was x cubed. Yep, x cubed plus 16. So I'm looking, okay. Trick question here. He's asking me, do I want the positive or the negative? No, wait, that was positive 2/3 x squared plus 16, negative 2/3 x squared plus 16, negative 2/3 x cubed plus, 8, so that's why that's wrong. Okay, so our possibilities are these two. So I have to look at the question and come up with the realization of which one would I use. I'm going to plead ignorance because the only reason I would choose positive is because it's a principle. You know, square root of both sides, I take the positive. But I'll be honest with you, I gotta phone a friend, find out why one or the other would have been better. I'll get back to you on that. 10. Oh, this is just setting it up. You have somebody asked for 10 as well. Realize what I told you to do. You pretend that you're integrating. In this case, my function is probably e because my u is a function of x. I have a function of x down here. So I'm pretending I'm doing e to the u is what I want is du. That's what I want. In order to integrate e to something, I need to have its derivative. So I'm looking at this something. If I let u equal x to the half, then I'll ask myself, what is du then? Then du would have to be x to the negative half divided by 1/2. So I need, that actually looks in disguise as 2 over this, I lost my half here. 2 over the square root of x. Well, if you look very carefully, I have the square root of x down there. It's perfect. I have everything I need, u du. What I don't have is the 2. So what I just do is I'm going to take my magic pencil and say, I will put a 2 there. 2 there. There's my 2 over the square root of x. But I can't just put it there. My magic pencil says I also have to cancel it out. So what I'm really looking at is I'm 1/2, I'm integrating, and I'm turning it back into x's. So I'm putting these numbers back in, 1 to 4. And there is a way to do it. Well, actually, I'm looking at what he has. Yeah, I can see why you would have trouble with it. So 1 to 4, e to the x to the half over x to the half. And then my 2 is right here, there. So dx. That answer is not there. Okay? So what he did was, pay attention here, guys. What he did is he didn't convert back to x's. He left it with u's. He left it with edu. What he's testing you on is, do you know that if I go back, if I leave it in u's, do my limits change? Do my limits change? And that's what he's testing you on. Do my limits change? And of course, if you leave it in u's, yes, they do. Most of the time, I don't ever worry about that. I just integrate, put it back into x's, and use the original limits. But since I obviously have to do this 1/2 e to the u, and these two numbers change, he is testing me on that. It doesn't happen very often. It happens on one multiple choice question on an AP exam, but this year there's no multiple choice, so it's not going to happen. But anyway, let's just figure out how you would do it. If I said u was equal to x to the half, and I'm letting x equal to one of my limits, well, I had a 4. If I had a 1 and a 4, so if I do both, then u, in this case, would be the square root of 1, which is 1. And if I use a 4, u would be square root of 4, which is 2. So instead of 1 to 4, I'm doing 1 to 2. So then I would change that to 1 to 2. 1/2 from 1 to 2 of e to the u du. 1/2, 1 to 2. 1/2, 1 to 2. Yeah, I think it's that one. Well, no, for it's only one that has a 1/2 in it. But these two are tricking you on that 2-bit because I added the 2 with my magic pencil, but I had that really goes away. That really becomes the du part. So if you look up here, I needed a 2 over the square root of x, and I didn't have the 2, so I added it here, canceling out here, so that just becomes my u. I hope that enlightens you. 11. Let's see how ugly 11 is. Again, I'm integrating. This time I don't know what he did because he has answers. So I'm just going to do it my way. I'm going to let u equal to negative 4x because I want to integrate, again, e to the u du. So if that is true, if u is negative 4x, then du is going to have to be a negative 4 dx. Well, what am I missing? I have the dx. I have e to the u. I don't have du. I need a negative 4. So I magically put it in there, negative 4. But it really just goes away, but this over here, negative 1/4 does not. Because I have to cancel out multiplying by a negative 4 is dividing by a negative 4, so that turns into a negative 1/4. So if you look very carefully, I'm integrating e to the u du. I know, I haven't addressed these limits. It's because I typically just do the indefinite integral and say the answer is going to be e to the u plus c. So if I was going to do the definite integral, then I'm going to plug back into what u was. U was a negative 4x. So my answer really is e to the negative 4x from my original limits. And the reason I can use my original limits is I substituted it back into x's, 0 to 1. I'll do it with leaving it as u stuff here in a second here. No, don't forget I had my negative 1/4. Oops. I almost forgot that part. But anyway, either way, it's in both pieces, okay? Because there was this negative, it's just gone because du was negative 4 dx. So du's gone. Plug in my 1. That's negative 1/4. What I do, I take that negative 1/4 and I just put it on the outside. And I say e to the negative 4 minus e to the 0. That turns into negative 1/4, 1 over e to the 4. I'm just guessing what he might be doing. Minus 1. It's anything to the 0 power. If I'm looking at all those answers, he's trying to simplify it all. So I'm going to take a guess and say he's going to multiply this by e to the 4th over e to the 4th. Negative 1/4. Maybe I should look at the answers to see, but the numerator is 1 minus e to the 4th all over e to the 4th. So that would be a pretty good answer. I mean, this answer is pretty good too. Just leaving it as negative 1/4 times e to the negative 4th minus 1. That's a good answer. Or leaving it like this. Negative 1/4 times 1 over e to the 4th minus 1. That's a good answer. Or combining into one fraction is a good answer. It's just a mystery to me which one he wants. Let's go look. This didn't come up at all. This didn't come up at all. This is almost an answer I had. It's missing e to the negative 4th minus 1. I have that. E to the negative 4th minus 1. But what doesn't he have? He doesn't have that negative 1/4 on the outside which is a very common mistake. I make that mistake all the time. So this answer is close, but because he didn't divide by a -4, that's the problem. Now this one, look at this. Did he divide by a -4? I know what you're thinking. He only divided by a 4. But look at, he switched these two around. He made the 1 positive over here, and the e to the -4, he made it negative. Therefore, he did distribute the -4 to e to the -4 minus 1. He did distribute, because that turns into negative e to the -4 over 4 plus 1 over 4. But he didn't want to see the negative in front, so he rewrote it. That is our answer. I can understand why you'd have trouble. All right, last one here. It looks really ugly. Looks very ugly. Definitely there's 2 functions in there. Why don't I see what happens if I make the bottom u? I'm just playing. I don't know. U equals 2x squared minus 4. Then du would have to be 2x dx. Ooh, I like it. I have an x dx in the problem. How can I make it a 2? Put a 2 there, then divide by it. So what am I really looking at? I'm looking at a 1/2 integrate du over u. That's exciting, because whenever I have du over u, I know I'm looking at the natural log. So I know it can't be a, and it can't be b, and it can't be e. So if you're in a hurry, just pick one. Well, which one would you pick? The one with a half, right? So it's probably this one. Let's see. Let's plug in our x's. Let's put it back into x's. 1/2 integrate, no, 1/2 natural log of u plus c. 1/2 natural log of u, x squared minus 4. Absolute value of x squared minus 4 plus c. There it is. Okay. Cool beans. I still apologize for not being smart enough to know why I would take positive or negative on that number 9, wasn't it? Yes. I can't think of a reason right now. I might have to email the author and ask him what would be the reason you would pick one or the other. But I don't know everything. I just know a little bit about a lot of things. All right, let me set this up and put it on Google so you guys can have it. And stay tuned for tomorrow's lecture to be put online, because I want to get that out of the way. It's our major lesson. Major lesson I have to get through for AP, and we're almost done. Bye.